There we go. Okay, now we the 200%. Maybe yeah, it's way overkill. Drop down to 100. You're a sitter, aren't you, as I recall?
Sorry?
You're a sitter, as I recall.
No, I tend to.
You're a
Well,
wanderer?
I'm a sitter if I'm coding,
Okay.
but
Don't
otherwise
worry, we
I
can
will be.
follow
We
I
can
will
follow
be-
you around.
I will
We have a
be
camera
walking
operator.
around.
Don't worry, you do you.
Yeah,
okay?
I got you.
Good.
I'll deal with it.
How many minutes do I have?
Minutes?
Yeah.
76.
No, before I leave.
Oh.
I gotta run. I'm gonna run to my car, but I won't do
Go.
it until
Go.
after.
We're fixing audio anyway.
Okay.
So you have it until the audio
I
works.
was bring my camera.
Oh,
Yeah,
cool.
so can I grab Seth's cable out here just to
Go for it.
check that PowerPoint is going to play ball?
Here, let me just grab my laptop. We don't need that anymore.
Yeah, John, do you want me to move my laptop?
That would be.
Here, pop it up where mine was.
Okay. Cool. I'll also going to check how far away I can read the notes.
Go for it.
Which is
High quality production here.
High quality.
We've only been trying to make this. Actually, we did a good job.
Yeah, we're doing a fun job.
Is there audio?
Yeah, there's
No.
audio.
Oh,
And bloody-tastic.
That kind of audio.
Oh, yeah.
I have no audio.
You have enough water up there.
I can grab a couple waters.
Go
You
grab
sit
some
down.
water.
I will definitely need water. Yeah. Yeah, I'm afraid the audio will only be provided by me, which is not necessarily ideal.
I thought they were going to like Is it general happiness?
Well, it's not showing my laptop at the minute, which is.
Was it?
Let's see whether that's.
Oh, you're on the
No, I'm almost in. No, it's as
Hold
if
on, let me
it
make sure.
hasn't-
Go back to the. Go to game. Oh, game capture's working.
Yeah, it's working.
It's not though.
What?
We're not out. Oh, hold on. This is in, right?
Unplug and plug it back in.
Okay. So, I think this was showing.
Hold on. We have it over here.
All right.
Oh, there we go. We're in.
Okay. Cool.
Magic.
Just don't break it.
Magic works.
This is literally being held together with magic, post-it notes, and gum.
So, if I present, wait, I have.
There you go.
Where are notes? Show me notes. Where are my notes?
Did you check what we had when we I just realized they're going to go hear anything we say right here. Did you check swags? You were going to go online and make sure we had swags?
I'll do it right now.
Dustin, can you give Seth a 20, when he's 20 minutes in, can you let him know?
Are you serious? That time?
What?
I can literally do that. And then just give them
Well, I
away.
figure with you guys sitting right here.
Yeah.
Come on. Show. Well, I'm. Ah, good. We now have notes there. Do I have notes here? Yes. Okay.
This is increasingly looking less scratchy. We also kind of stacked the odds against a blouse just because of moving and the.
Okay. I'm going to hope that I can see enough of my notes. The presenter view never shows huge amounts. I'm
Do
going
you want us to go steal a monitor from someone's workstation?
No, it's PowerPoint itself. Is just
Oh, yeah.
It only shows the notes in a portion of the screen, and that's. Let me just see if I can adjust that even more.
I know you can slide it up. Oh, that.
Let's see if that should give me enough. I reckon. Because some of the slides had quite a few notes. Right.
I think so. trying to get back.
Okay.
What's the
I will
web-
get better at this talk.
I've
But
been
it's-
checking.
Other thing you could do is if just have two computers that aren't synchronized, have one just have the notes. Don't go present, you do your own presentation.
Oh, I see. Yeah,
And you
yeah,
can
yeah.
full screen the notes on
Right,
one. But
yeah,
it's up
or
to you,
just-
then it's up to you to press them both
That's
simultaneously.
true. The other thing that I can do is I have the notes in a document. If there's an easy way of printing them, but let's not worry.
You want to
That's the audio.
At Cobash, there's a business thing I can easily print for that. Right, have a.
Where's July? Alternatively, I can literally just put my laptop up here with notes if you want.
No, it'll be fine. It'll be fine. I will have to read through.
Seth, are you ready
Okay,
for
audio works.
Are you ready for intro?
So,
Are you ready for Dave to intro Seth and get started? Or is
yeah.
there anything you want?
I don't know what you did after. Like my last 3 years,
Something like ready.
Yeah. That I need to remember to sing, how to sing.
Do you want me to sing with you? I'll go a third below or a third above. Of this
how to
Sorry? If it's easy enough to do, that would be awesome. But yeah, absolutely. So it's just a Word doc. That's easy enough for you. When Chrome wakes up.
All right. Blinding light aside. Thank you all for coming.
stay out of the light.
Stay out of the light, indeed. So before we get to speakers, we have a special guest who I'm literally just up here to introduce. So Dave.
My name is David. I used to be the president of the gang. I'm really excited to come back here. I was thrilled to come back last year when John Skeet presented. I got to introduce him, and we have John Skeet again tonight here. No pressure, but it's going to be an awesome presentation. But before John goes on, we've got a few minutes of a returning speaker. Seth Juarez is an advocate
Just one
at
would be
Microsoft. I forgot his full title. We're advocate in it.
It does.
He is here, and I don't know how many people were around when I was the president of the gang. A few of you were. So what I used to do is I would introduce speakers, and I would always tell the story of how I met them. And so I actually remember very distinctly. I was at Codestock about 8 years ago. Codestock in Tennessee, and we're all sitting on the back patio drinking some non-alcoholic beverages of the hotel, and everybody, literally everybody, was talking about this guy who gave a talk on machine learning. So the question was, who's this guy Seth, and what's this machine learning thing that he's talking about? Most of us hadn't even heard of it. But it had created this huge buzz in the industry 8 years ago, which was a precursor of really the industry. Now machine learning, you can't, if you want to increase the spam on your LinkedIn site, just add the words machine and learning somewhere in your profile. Spam will go up and down exponentially. It's really a great thing. So I missed it, and the next year at Codestock I got to see that. I finally got to see him, and then I begged him to come and speak at GAG. So that's how I got to know Seth. And today I'm here, and I'm very privileged to call Seth a friend of mine, and a great speaker and a great technologist. Please give a warm welcome to Seth Juarez.
I feel bad. I'm like the previews before a movie where it's like, gosh, man, this is taking forever.
Time's up.
Dr. Dang. So yeah, so if I start
long
to
as you
see
like to.
if I start to see an eye roll or two, it's okay. I have teenagers, and so I'll work through the first couple. Today we're going to talk about deep learning just a little tiny bit because I only have like 20 or so minutes. And so I'll introduce you to the concept of machine learning in general, how one goes about building these things, and then I'll start showing you the infrastructure, right? And then I'll show you what that looks like in TensorFlow in this example. How many of you have heard of machine learning? Yeah, so I started talking about it before it was cool, right? And so now I feel like I'm a little bit cool, but it also feels like now, how many of you have had the dude from the place come in and say, oh, we totally need to add machine learning to everything. Right? Has that happened to you? They just come in, hey, can we add some machine learning? And for some of us, it's like, well, what the heck does that even mean? What does that even mean? And so today I'm going to try to introduce you to why machine learning is different, but it's kind of the same. And then I'm going to show you the beginning machinery for doing something called deep learning. Now, machine learning and deep learning are not the same thing. Machine learning is a general way of doing computing. Deep learning is just an instance of doing it that way. Okay, so that's what we're going to talk about here for about 20 minutes. Okay, so let's pretend today you work at a bank. Anyone work at a bank?
Yeah.
Sorry. At the bank, they should be on dirty jobs because I mean their databases have got to be completely screwed, right? So imagine you work at a bank and the manager, she comes down and she says, okay, today we want to be able to recognize how many numbers, like the numbers, you write the check, you write a check out and there's numbers on there, and she says to you, real easy, everyone can do your program, right? Super easy. We just want you to add this one feature, this one thing, where you have to recognize the number that's on the check. That's it. This is an easy thing. Just one button. Have you ever had the dude come and say, just add this button? And it has to launch the SpaceX rocket and not explode and land it too. So yeah, so imagine that this is the problem that you're coming with, right? And your manager says you need to, she says you need to make this work, and you have, how long does it take? A week? Right. I mean, that feels like a lot. So what, next weekend? And so how would you go about solving this problem? And this is, now I like to ask questions and have people respond. I used to teach high school, so awkward silence is mostly awkward for you. How would you go about? Well, the first thing you would do is, and I would do, is we would do this, right? Let's just pretend that we've found a way to isolate every single digit, and we want to pass it in. So how would you write this thing? What would you do?
I would write a program in Prolog, which I did in my computer science course a long time ago.
We should bar him from answering questions.
I can just ask questions.
Like
instead.
I literally installed Prolog one time, and I looked at it, and I was like, this is definitely French. Isn't it from Enria?
I don't know. It's
Someone look this up. I think it's literally a French language. Someone looking this up. That's a good question. But before we would think about machine learning, how would you solve it? Yes.
Optical scanning.
Optical scanning. Okay, but now you have a picture, right?
Yep.
Now that you've scanned it, you have a picture. Now what do you do? I'm going to go back. So traditionally what we would do is we would all like look at these pictures and we'd be like, yeah. Let's see. So this is black and white. So what I'm going to do is I'm going to look at all the pixels, and if there's like pixels in the middle-ish, return 1. Got the ones, right? We got those. And then you would be like, okay, if there's like no pictures like in the middle-ish, but then there is some in the outer-ish. This is computer science terms I learned in college, right? Then 0, right? And then we build this elaborate set of functions, right? Because we would look at a bunch of pictures and we would say, you know what? I think I can come up with a strategy or a series of steps to solve this problem, right? That's what we would do. And that's okay, because that's what programmers do. They give us a problem, we figure out the steps, we put it in the code, it doesn't work, then we do it again, right? Then it crashes in production, you know, that kind of thing. But eventually it gets to a place where these series of steps are the right thing. Well, it turns out that writing this function is actually hard. There's no way for it, because then one day someone's going to write a 9 and you're going to guess a 0, and then there goes that check, right? Because if you had a 900 and instead you put 000, that's an issue for your bank. So writing this function is very difficult. And these classes of function are called h of x for machine learning. They're called hypothesis function. And the difference between machine learning and regular programming is we are used to creating a series of steps to solve an issue with code, right? We think about it, we have a bunch of if statements, we do switch case, we do a bunch of stuff. In machine learning, it's different. Machine learning, instead, we give it examples of the right thing, and it will make this function for you. And that sounds creepy, but it really isn't. It's not. So again, I'm talking about machine learning in general, not deep learning. The difference between regular programming and machine learning is in machine learning, instead of giving it steps to solve a problem, we instead give it examples of the right thing. So in this case, we're going to give it an image, and we're going to say this is the number 1. We give it another image, this is the number 2, and we give it a lot of those images, and it will write this h of x function. So the question is, how does it do that? I don't remember what the next slide is. Oh, okay. No, we're not going to do how it does that. Machine learning can only answer 5 questions. It turns out that it looks smart because when you compose these things together, it looks really intelligent. Like driving a self-driving car is literally a bunch of, you can reduce it down to a bunch of yes, no questions. Should I brake? Should I turn? How fast should I go? Well, that's a regression. So notice that how much or how many is like how fast should I go? Right? Which class does this belong to? Could be like, is this the turning left class or the turning right class? Right? For example, our different groups. Let's talk about what's around me. You can group things that way. And then, is this weird? If something's coming up that's not what you expect, notice that once you start to put all of these together, there seems to be intelligence. But these things are not smart. They're not, it's literally a bunch of vectors. That's all it is. Okay, so again, the principle of the thing is machine learning is you give it examples with the right answer, it figures it out. Yes, sir?
Is the digit thing the second one?
Yes.
Okay.
Wait, no, the digit, yes, this one. Absolutely, good, yes, good question. I brought him to keep me honest. He flew all the way from the UK to make sure that this 20-minute lightning talk was. Okay, so these are what these are called. What's that?
Who's he work for?
He works for Google. Don't say Google. I mean, like TensorFlow, I'm showing it. It's Google, right?
Yeah.
Absolutely.
We're all copacetic. Just use our cloud. So anyways, how many is regression? Which does this belong to is classification, clustering on. Those are the 5 kinds of things that machine learning can answer. We're going to focus on this one today with deep learning, but with deep learning in particular, but machine learning can do all of these, and there's different techniques to do it where you give it data and yes, sir?
What do you do when like the color variation? There's color variation in the way that when they write down.
Yeah, so what I do is I just convert it to grayscale, shrink the image to the size that it expects, and then it goes from there. So, and we'll talk about the process, because notice that now you're starting to see, well, the machine is stupid. So now I have to, if you train it a certain way, you have to give it the exact same kind of input, or otherwise it's going to be stupid.
Do you use anything like fuzzy logic, weighting?
No.
Okay.
What we do is we let the algorithm make the decision.
Okay.
You see what I'm saying? And so, like, there's a lot of implicit trust in these algorithms, but I'll show you how you can score them and make sure they're doing the right thing. So does this make sense? Machine learning is a different way of programming where instead of doing steps, we instead give it examples of the thing and then the right answer, and then it does its thing. Okay, so this is called supervised learning. This is called unsupervised learning. We're going to focus on classification today, if that's okay, because we're going to do the digit stuff. So here's the process. You need to identify your data. For us, we have pictures, right? Then we need to format it in a way that is the same way every time, or we need to analyze it. Maybe we have a completely blank image and that's just worthless, so throw it out, right? So you need to go through your data. That's why when we talk about bankers and their databases, it's called dirty jobs, because there's a lot of data cleaning that needs to happen when you're doing prediction. So that's what that part is. Once you have your data in a really good form, you make this h of x function called a model, and you do that by giving it the data, giving it the right answer, and then it does some thing. And I'll tell you what that thing looks like for deep learning. Once you build this model, you use it to predict, and that's it. So this model, imagine it's just like an assembly or like a jar file that has something that you call that says int get digit picture, and then it returns the right thing. Okay, and I'll show you like what that looks like in WPF using a TensorFlow protobuf model, which is Google stuff. I wanted to use that because he came all the way. Benefit. So let's talk about what this looks like in more detail so that you can get a sense. So we're talking about, this is a guy or gal that owns a tennis shop, and they want to know how many courts to keep open, and this is their historical data. That if the outlook was sunny and the temperature was low and it was windy, then people came out to play, so you got to staff up a little bit more. This is your data. In machine learning, the label Y is the thing that's the right answer. The feature x is this set of things that we're going to use to learn, and then the values of x are these instances of things. Okay, so that's what that is. But in reality, this is actually what your data looks like, right? Because every freaking time Jim puts the age in the name column, and you cannot, for whatever you tell him he does it, you have to do some cleaning. So you've got to clean that up. Like for example, and this is the first I'm using this thing today. What the heck is? Thank you.
Come on, everyone.
I know, right? No? Like, what is it? What's a turtle plow, right? I just bought this, so I got to figure out.
Is that powered by machine learning?
What's that?
Is that powered by machine learning?
Probably not.
Oh.
Yeah. So again, this is what we call yak shaving in programming. That's what this is, and I pulled it in a wiki image off of that thing. All right, so once you do that, you have to convert it into numbers. Because in machine learning, everything uses, well, almost everything, at least all of the cool things use linear algebra. And so you got to find a way to turn that into numbers. Okay? For us, because we're using digits, it's easy because the format that I'm going to show you is super easy. It's a 28 by 28 image that has a 0 where there's no color, and then between 0 and 255 up. So it's the negative, because 255, if it's grayscale, 255, 250, FFF is white, but so imagine a negative image with where it's black background and the white. That's what, and I'll show you what I do. Okay, so then you make a model, and then you do predictions. So in this case, it's a decision tree model. This isn't deep learning, but decision tree model. You use that to predict. So if it's sunny, temperature's low, and it's not windy, are people going to come play at tennis? Okay, so the outlook is, thank you for allowing me this opportunity again, too. So if the outlook is sunny and the temperature is low, are people going to come play? I'm trying to give you some hints here. Yeah. Outlook, yeah, they will. And that's what the model says, so that's what you use to predict. Okay. So yeah, that's what that is. So how do you know if this thing is doing the right thing? Right, because you give it all this data and it makes something. Do you know what the thing is? No, we know it's h of x, the hypothesis function. We know it's something that gets digits, and how do you know it's actually working? So instead of just throwing all the data at it, you throw a certain percentage of the data at it, it builds the thing, and then you test it with the other percentage. Some even separate this into 3 different sets, one for training, one for dev work while you're deving, and then one for test, when you're doing the real test. And so you can do that as well. So that's how you know these things are actually working. So if you have yes, sir?
Do you need to do that? Or I would have thought you should just be able to throw all your data and the infrastructure can say, well, I'll train on this 80% and test on that 20% and then do it the other way around.
You certainly can, and there's machinery that does that, but I want people to be aware that this is how you know it's testing. So yeah, there's even a smart way where it does, I think it's called cross-validation. Did I get that right?
Yeah.
Jennifer's here to make sure. Cross-validation is where instead you get 20% chunks, and then you take 4 of them, and then use the other way, and then you keep switching them out until the model comes to something. And so notice that there's got to be some, you just don't throw this thing out, because if you're running a cancer detection algorithm, we want to be sure. And there's another way to be sure, right? Because it's not just how accurate you are. How sure do you want to be? For example, if we guess the right thing, how good are we at guessing the right thing? That's called precision. How good are we at guessing truth? That's called recall. So if you're writing a cancer detection algorithm, which one do you want to optimize for, recall or precision? Remembering that if the computer even thinks there's a vague chance we want to guess, yeah, you should go see somebody. So are we optimizing for precision or recall? I'll let you think about that one. How good are we at guessing the truth versus how positive are we, or how good are we when we're being positive? Right? And so I'll leave that as an exercise to learner, if that's okay. So think about that. There's even more to just being accurate, right? And in fact, if you go and Wikipedia the confusion matrix, there's one for this, one for this, one for these, one for these, and so there's a name for all of them. Those are the ones that we use for checking. So now you see that this isn't just a bunch of hogwash, right? We're not just doing a magical function that something's happening. So the question becomes then, how do we build this h of x? And in this case, we're going to use something called deep learning, but we're not going to be able to get all the way to deep learning because John Skeet is here, right? And he can't. I promised him I would not take so long. So what goes into this X right now? And I'm going to show you what that looks like for this particular problem. Remember, it's the digit problem, so let me move this over. Sorry for the close-up. All right, so I'm going to go here to this. These are the pictures that are going in. So these are what the 2s look like. Oh, I'm trying to zoom in here. These are what the 2s look like. These are 28 by 28 pictures, right? That have, remember, because it's grayscale, and so this is 0, and this is 255 in the middle. And then when it's actually translated into something that the computer is going to use, it looks like, stand by, it looks like, oh, I think I might have it open already. Yes, it looks like that. Now this is weird, right? I told you label was the thing it was going to guess, but that doesn't look like an int. This is called one-hot encoding, where it's literally saying 0, 1, 2, 3, 4, 5, 6. This is a 7. That's what that's doing. Really? And so this is a 28 by 28 image, so 28 times 28, all the way out there, and this thing says this is a 7, this is a 0, 1, 2, this is a 1, this is a 0, this is, do you see it? This is what the computer gets. And that's after we did all of the nice washing machine stuff on our data. Okay. So now the question is, now that we know what this thing looks like, what do we build? So I'm going to show you something stupid. And we'll start with that, and then we'll make it better. How much time do I have?
You're good.
Oh, he's not good. He never starts. You have 20 minutes. Wow. Awesome. So now we know what comes in, and we know what comes out. And this is where we're going to get into a tiny bit of maths. And I say maths because in the UK they have more than one, right? And here we have one. I don't know, what's the extra math you have?
Right maths.
Oh, yeah, right, of course. So,
we don't have alternative maths.
No, not alternative, but extra. Okay, so let's make this thing. So let's talk about what this means real quick, and then I'll show you what it looks like and we'll build this up so you can get a sense. If this doesn't make sense, it's because I'm not explaining it right, not because you don't understand. Please understand this, okay? Like, I hate this presenter deal where they explain something to sound smart instead of explaining something to make you understand. If I'm explaining something to sound smart, I'm failing. And so if it doesn't make sense, you tell me and I will go back, okay? Because maybe I don't understand it. I'll be like, oh, that's a good question. John, will you write that down? Because that's what he came all in. So X is this thing that's coming in, right? These are these little values from 0 to 255, right? And n in this case is 28 times 28, which I think is 784, if I'm not mistaken. And you're like, wow, you multiply so fast. No, I actually wrote code a lot, and I had to type that number in specifically. So what we're going to do is we're going to take each of these little x's, and we're going to multiply it by this little dot, and then we're going to aggregate them all together and add them. Okay? Makes sense? It's super easy. So if there's an x1, we multiply it times a w1. If there's an x2, we'll call these w's if that's okay. We'll take an x2, multiply it by w2 all the way to xn, which is 784 times w784. We take all those things and we smoosh them together into addition, and then there's some number comes out. But that's not all the way sufficient, right? Because we need to have how many outputs? Let me show you what the output looks like here. Sorry, I'm a little hobbly. How many outputs do we have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there should be 10. 0, 1. Oh, 1, 2, 3. Sorry. Yeah, there's 10. You see what I did there? That's where the extra math comes from, I think, in the UK. There you go. Okay, so makes it, we need to make this to have not just one number come out. We need to make it have 10 numbers come out. So let's be a little more tricksy about this, and let's do something like this. Right? So we'll have 10 of these deals out here. We'll have 784 of these deals, 784 of these deals. And what we'll do is we'll do the same thing like we did before. Okay, we multiply this thing, and then there's a number that comes out. But then we'll also do this one at the same time. And we'll do this one at the same time all the way. You see what's happening? So how many W's are we going to have?
7,884.
Well, we have these W's, right, which is 784, but we need a W for this one. We need a W for this one. We need a W for this one. Shoot, if only there was a way to represent this compactly. I remember the first time I took linear algebra, no joke, I sat there and thought, this is the stupidest maths I have ever seen. And then I looked at something like this and I was like, oh crap. Woo, this turns out to be a 784 by 10 matrix. I might have the transpose wrong. Let me show you what it looks like in math. It's just this thing. Y transpose, this is a bias term that we add just to make it mathematically better. But W is this matrix, 784 by 10. Yes, times X, right, which is 784 thingies, times B, which is a bias. Imagine just adding another feature that's all ones. In this case, that's what and then the thing comes out here, and so this is what it looks like in maths with matrices. Yeah? We good so far? Okay. Okay, so notice we're getting 10 of these out. We have 10, because anytime I look at this kind of multiplication, I always think of like the Cookie Monster. This is the dumbest thing, don't laugh at me. Okay, maybe laugh a little. I take this thing and it's like, I turn it over and I go, right? Right? This thing goes, those are the sounds in my head when I'm doing math. It's not, I should never teach it. Right? And this turns into a 10 thing, that's a column matrix, and then you add it to this 10 thing, and then this thing comes out. So now what's the question? We've made this new h of x function, right? H of x equals W transpose x plus B. Easy. What's the question now?
How do you find the way?
How do you find this thing? And this is where we use calculus. It's okay. If you didn't take calculus, it's okay. And I was supposed to draw a picture, but I ran out of time. What we do is we come up with a function that says how wrong. Am I 5 minutes? Man, I'm doing this good. Good. Almost done. Almost done. So now we need to come up with a function that tells us how bad it is. How bad is this function that we have? So remember, what is y?
Oh, I love that function.
Y is the right answer.
Right.
What is h? That's our magic function that uses W transpose x plus b. If we subtract these two things, if it's 0, what does that mean? We got it right, because they're exactly the same. If it's different, what does that mean? We got it wrong. And the bigger it is, the wronger it becomes. That is also not a maths term from the UK. That's wronger is me, all me, right? And the cool thing about this is once you have this error function, right, and then here you would just put W transpose x plus b. Right? You can just replace it because that's the niceness of math. And this is all vectors and matrices, so but calculus works the same in any dimension. It's really nice that way, especially since we're in Hilbert space. So when you have this thing here, now what you can do is you can use calculus. Now, and I want you to, and I was going to draw a picture, but I ran out of time. Anyone know what x squared looks like?
Yeah.
Yeah, it's the u. It's the u. It's that really good u. And the thing is, with this function, we actually want to minimize this function. We want this to be the least error-ness as possible. Are you okay with this? Less, okay, thank you. I knew there's, again. We want this to be the least error-y possible. So imagine this is like a x squared function, right? Super nice. So imagine you have the u, and the cool thing about calculus is when you look at this thing, dy by dx, have you seen that? Dy by dx,
Yeah.
it's the derivative.
Yeah.
D just means a little bit of y, and so dy is a little bit of y, and dx is a little bit of x. And if you think about it, it makes a tiny little triangle on the line, and it tells you the slope. And the funny thing about calculus is that when that slope is at 0 for x squared, it's a line, you are at the minimum. So how do you get to the minimum? Well, here's the fun thing. With calculus, if you evaluate the function at any point x squared, and then you look at the derivative and go in the direction of the negative derivative, it takes you to that little hill. And I want to draw it. So imagine there's the, I need to draw this, I didn't get a chance. So you have the u, turns out the derivative of x squared is 2x. right? And if you're at minus 2 with x squared, 2 times minus 2 is negative 4. And if you want to go to where the 0 is, right, because it's at 0, you want to go this way. And so if you go negative the direction of the derivative, which is negative negative 4, you're going to go that way. But then you have to have this funny thing, right? Because if you go too far, you might overshoot, and then you'll start bouncing around the U every time, like how I play basketball. It never went in, it just bounced every in until it came out, right? And so it turns out we wanted to get into the basket, we have to adjust this thing. This algorithm of looking at the function and going in the direction of the negative gradient until you find the minimum is called gradient descent. So now that we have this fun error function, which looks like the U function, right? Because we just take the 2 over and then we take the derivative, right? Because we're trying to find the best W, so we differentiate with respect to the W. Then we can solve using gradient descent. Are we okay? Was that too much?
It's all good, but why is there a half? I keep wondering that.
It's a great question. It turns out that because of, this is going to sound super dumb, but it actually makes the math nicer, because when you differentiate, you take the 2 over, and it disappears, and it turns out that the minimum of 1/2 x squared is the same as x squared. So it just makes it so we don't have to have these floating constants around, because nobody cares about constants.
No.
Look at our news. Just kidding, that was a joke.
Is that one of those up and down lines?
Oh, that's good. This actually turns out to be the norm, L2 norm, which is the square root. Remember when you take in the norm, it's like the distance? So, for example, the norm of x minus y turns out to be the distance of the thing. Did I get that right? Distance of the hypotenuse. So this is just a way of doing it. But again, the notion is you have this function here. You have the right answer here. You want to minimize the difference between them. You use calculus. Then you use gradient descent to find it. And then that will produce a W that you want. So let me show you how you do that in TensorFlow. With TensorFlow, the way you do it is you create this graph, which looks like this, with your stuff, and then you tell it to use gradient descent to optimize the cost function, and then it outputs a W for you, and then the B. This looks like, let me show you what this looks like, and this is Python, if that's okay. This is the X that's coming in. This is the Y that's coming in, because we have those two. We're going to use a linear model. This tells us how accurate it is, right? So for example, if it's how close it is to the actual thing, and then this is the cost function. And I need to change, you can do any kind of loss function you want, and then this is the optimizer. So here's the thing with machine learning that you need to understand. This is why it's called a science. I wish I should have explained science. I don't think it is what everyone thinks it is. Science is glorified guess and check. It's kind of squishy that way. And so machine learning is that way too. So in this case, I'm going to use a linear model for predicting. So let me go to the definition here. By the way, do you guys know that Visual Studio can do Python? So there's... Oh yes, absolutely. Thank you for that. Right, there's W, there's B, matrix multiply, right? And this will output the right shape just because of the way the thing is. So you don't see the sum. So now the cost function looks like this. If we're doing just a regular built-in squared error loss, it looks like this. I'm doing the mean, right, which is similar, except you're divided by 1 over n, right? So I should change it to the squared error loss. And I couldn't get it to run, so I'm sorry about that. So I'll change this here to the loss function, right? And then the optimizers, again, it's SGD was for stochastic gradient descent, which means that you're giving it batches of information, and then it's updating W as it goes. And that's what happens there. And then it trains the model by just stepping through and optimizing. So for every input, I did Control MO, and now everything is like lowercase. It's just going to go ahead and run the optimizer in a loop. So here's the thing about these particular models is that they actually get smarter the more data you give them. It makes sense why, right? Because when you're optimizing the thing, if you're giving it more and more and more data, it can actually step into the right spot, which is nice, right? And the more data you give it, the smarter it gets. It also brings up an issue of computational power, right? You want to run these things on huge graphics cards because they're really good at doing matrix multiplication. Okay, so now let me show you, because my time is, I think I'm over time. Let me show you what that looks like. So once this is done, I save the model out into a protobuf file, and then I use it in a regular application. So let me go to Solution Explorer here, and let me go to this code right here. So here's me pulling in a digit from the can I draw it on WPF, and then I render this bitmap out. I resize it to the right thing, and then I literally make the same vector that you would see, and I have to do a 255 minus, right, so that it's black on the back. So this is all garbage code, but you have to do it. And then down here, you can see I'm importing this graph, right? I'm importing the model. I'm pushing in. I'm running this model with this value that I got from the actual thing that I write in, and then it'll give me an answer. So let me show you that works. And this model, I don't know if it's the best one, so sometimes it's going to get it wrong, but that's okay. So now I just do 3. I don't think it recognizes this one right, to be honest. Oh, it did a good job. And then I do 2 here. It's going to say, oh, that's not good. Let me do 7. By the way, if you look over to the bottom right, you can see, like, this is what the computer is seeing. Yes?
How long are you probably?
Not very many. It's because I wanted it to run fast for demo. But if I sat there and ran it for a very long time, it would get really good. And if I used deeper networks, it would make me better. Yes, sir?
If you try drawing a 1, you know how some people put a little hook on it?
Yeah, it's going to get it wrong because I didn't train it for very long. So you said like this?
Yeah, or a 7 with a line through it?
Yeah, it's not going to do a good job because I didn't train it with as much data. So now, notice that what we did is we built this thing that looks like a network, right? It had the middle W, and then it had the output. Now imagine just stacking a bunch of W's on top of each other. That's deep learning. Then you have other ones which are very specific. For example, if you want to work with images, you use convolutional neural networks, which actually look at little swatches of pictures and change the network in the way that looks. If you want to see, if you're going to CodeMatch, I think you're doing recurrent neural networks as well, which I haven't looked at those yet. But notice that now what we're doing is instead of just having that one layer, we have multiple layers. And so we have multiple W matrices that stack on top of each other, and then we put an output function. Like, you know how we just added them together? Then we can put a function over them like a softmax, which will take all of those things and put them into a probability. And so it will tell you the probability. So I think I've run out of time. Hopefully this gives you a good primer on how to think about machine learning. Thank you so very much. Before I go, I want to introduce the great and marvelous John Skeet. I remember the first time I went to Oz. Just kidding. He's a good friend. I've known him for many years. In fact, I learned C# from him from his first Manning publication. I don't know if it was your first, but the first version of C# from Manning. And I believe you're working on the 4th edition.
Indeed, yeah.
Okay. Take it away, my friend.
Cool. Thank you. Oh, wait.
You're fiddling with the position of the camera to make sure everybody's in focus, right?
All right.
You know how to do it,
Okay.
right?
Cool. Hi, folks. I'm John.
You want to take a
I should give a bit of background to this talk to start with. For one thing, please forgive me. Often with speakers, there's a danger that the audience falls asleep. Tonight, there's about equal chance that I may fall asleep. I got up at 5 o'clock this morning, and according to my body clock, it's now midnight. So, you know, been up for 19 hours. This is also the first time I've given this presentation. I'm later in the week on Friday morning going to give it at CodeMash. Then next Wednesday I'm giving it NDC. So I could really do with feedback. Partly, you know, afterwards, in the kitchen, whatever, but also potentially on, I think Wednesday would probably be a good time so that I've got time to change things on Thursday. but you've had a bit of time to think about the topic that I'm talking about. It's about as far from Seth's talk as possible, in that was all sort of deep techie things, and this is more thinking about coding in general, and in particular, it doesn't try to talk about machine learning. There's a whole, I started thinking, oh, should I try to apply the ideas of machine learning to what we'll talk about, which is art and craft and code and engineering and things. But I think that would have to be a whole other talk. So the background is I'm a big Stephen Sondheim fan. Any other Sondheim fans in the room? Okay, Dave, but that's about it. So the good news about that is that when I sing bits from the musical that I will sing in a minute, you won't know if it's wrong. This is good. On the other hand, it does mean that you're missing out. So if you take one lesson from today, it's that you should all go and see Stephen Sondheim shows, because they're awesome. And you probably know Stephen Sondheim if you've heard West Side Story, for example. He wrote the lyrics to West Side Story. But he's done far, far better things since, and he's awesome. Send in the Clowns, yes, from A Little Night Music, which he wrote lyrics and music to, and he's tended to do that since then. However, let me give you the opening line from Sunday in the Park with George. It is white, a blank page or canvas, the challenge to bring order to the whole through design, composition, tension, balance, light, and harmony. I've listened to those words, and every time since, for years and years, I thought, wow, starting with nothing, bringing order to the whole, and then specifically talking about design and composition. That isn't talking about art, that's talking about code. And I'm sure Stephen Sondheim wouldn't have thought about it in those terms at all, but that's what's triggered this. And back in August or September, I put together an abstract for CodeMash. I thought, if I don't do it now, I'll never get around to it. And since then, I've been procrastinating and putting off actually writing the talk until, in the last 36 hours or so. The other thing I should warn you about is that I wrote very rarely, in fact, this is the only time I remember doing so, I wrote out a full script for this talk, and it was 6,000 words long. Given that I always deviate from what I've thought I would said, if I actually said all of that, it would probably be about 3 hours. I'm going to aim for an hour, hope to be under an hour and a quarter, and it may be towards an hour and a half. I suspect I'll fall asleep before then, so there's a sort of safety valve there. But anyway, given how sort of meta this is, the idea is you'll take away and think not about whether you agree with what I've said or not, but about your own ideas about how code and art and craft interact. And then if you could email me to say which bits resonated, which bits made you think more, which bits maybe you completely disagreed with, but the fact that I said it made you think about it and disagree with it, then that can help train the model, as it were, for Friday and then for Wednesday. I'm hoping to give this talk many times and improve over time. It's one of those things. And it is somewhat experimental. It's not alone in being experimental. We're going to talk about a few works of art. So this is A Sunday Afternoon on the Island of La Grande Jatte by George Seurat. So Seurat lived from 1859 to 1891, so died really relatively young, and it took 2 years to do most of the painting, from 1884 to 1886. And there was a later stage painting the surround, which I'll talk about a bit later. And it's big. It is 3 meters wide by 2 meters high. And in fact, you may have seen this. Have you been to the Chicago Institute of Art? Yeah, I haven't seen it. I long to. One day I will. But it's a big painting. And he did it, the most of it, in 2 different phases. And as he went along, he used fewer and fewer colours. Basically, he was experimenting with light. So it looks here as if these are sort of pretty much a single colour, a little bit of gradients. There are actually lots of dots and small lines, sort of commas and things. And Seurat's idea was getting the colours to blend in your eye instead of on either the canvas or the palette. when I was researching this, I read some of the things that Sondheim was thinking about, and he'd researched a lot about the painting. And apparently when Seurat was painting, he had a palette at one of the stages. He had a palette of 16 colours. And he would allow himself to mix colours that were next to each other on the palette, but if there was a gap between the two colours, then they had to be mixed on the canvas and therefore in the eye. So he had these rules, and Sondheim tried to apply those rules to the musical, and it ended up being horrible, because you really don't want chords that are always notes that are only one note apart. It's ghastly. Anyway, so that is a Sunday afternoon on the island of Le Grand Jatte, and this is Sunday in the Park with George. So this came about 100 years later, in 1984, I think, with George Lapine, who he also wrote Into the Woods with, and a bunch of other things. So in musicals there is the score, the lyrics, and the book. And the book is sort of all the bits that aren't sung, pretty much. So if you've got something like Hamilton, Lin-Manuel Miranda did all of it, because he's just that good. Whereas Sondheim tends to write the lyrics and the score, but leaves the book to somebody else. So James Lapine was his collaborator on a bunch of things. I've said how this talk is experimental, and Seurat was experimenting with light. He called this a sort of scientific method, but it was definitely trying to be experimental and see what would happen. And Sunday in the Park with George was also experimental. It originally ran for just 25 performances off-Broadway in Playwrights Horizons. And we know it as a 2-act show. The second act was only performed in the last 3 of those 25 performances. And when one of the brilliant songs in it is called Finishing the Hat, and it's very complicated, and that only came sort of halfway through the run. And when it was introduced, Mandy Patinkin, who played George in the musical, actually had the script on stage while he was performing it for the first time, because he didn't want to get it wrong. Now, if you don't think you know Sunday in the Park with George, and you don't think you know Mandy Patinkin, you probably do if I say, "Hello, my name is Inigo Montoya. You killed my father. Prepare to die." So yeah, he played Inigo in The Princess Bride. Yes. So I should probably give a little bit of background to the story, because it will come in relevant. I notice I haven't mentioned code yet. I'll get there, I promise, before the hour and a half is up. So Sunday in the Park with George is set in 2 acts. The first act is in the time of George Seurat. Although Seurat himself was George with an S on the end, there are 2 Georges in Sunday in the Park with George, and they're both sort of singular. Although part of the point of it is that they are actually one person, sort of thematically. It gets quite complicated. Anyway, so first act, we have George Seurat and his girlfriend Dot. Whether that's a pun because Seurat was a pointillist and painted with dots, it's sort of unclear. And the point is that George is very unable to make and keep relationships, because he's so focused on living through his work that he is concentrating all the time and looking. There's a lot about him looking and seeing the world, which we will definitely come back to in terms of code. Whereas Dot is trying to concentrate, but she's far more in what we consider the real world, as it were. So she's more interested in going to the follies and getting George to commit to the relationship instead of to the work. Various other characters come and go and are eventually positioned into the work. And Dot ends up leaving George and marrying Louis the baker, but only after conceiving a daughter with George, called Marie. The first act ends with a scene on the island on Le Grand Jatte, and all the characters that George has sort of interacted with, they naturally go to some places, and George just moves them over slightly, and moves them a bit, and moves them a bit, and they're singing about how it's Sunday, and then eventually they all freeze, and then flying down or whatever comes a reproduction of the actual painting, and they're all in the exact pose. Glorious. So that's the first act. Second act starts at the same place, so the same picture, but with the characters in the picture complaining that it's hot up here. They're going from being painted to, this is now a painting on exhibition, but they are still feeling as though they're real characters. So there's layering of meaning and representation here, particularly when you bear in mind this is a musical with actors playing characters, playing people in a painting, but pretending that they're actually alive and can talk whilst being in a painting. They're complaining that, you know, my cigar never goes out because I'm in a painting. This idea of representation of different things being true compared with what you'd expect in the real world is another thing I will come back to. After that, we skip forward 100 years to the modern day and George and Marie. This time Marie is Dot's daughter and George is Marie's granddaughter, therefore George's great-grandson. Sorry, yeah, George is Marie's grandson, not granddaughter. So we've got a family tree of George, George's mum and dad, Marie, Dot and George. These are played by the same actor, and so are Marie and Dot. All of the characters from the first act come back in the second act, or all of the actors come back as slightly different characters. There's a lot of layering. George is also an artist and is losing contact with himself, with his art. He's finding a struggle to reconnect and find something new. Eventually he reconnects by finding, he goes back to Paris, or rather goes to Paris for the first time, to the island of Le Grand Jatte after his grandmother has died, and reconnects with the ghost of Dot, who encourages him to find something new. Okay, that was a long introduction. Where does the code fit in? We're going to talk about how code fits in terms of art, craft and engineering. And I've tried to represent this in a hopeless Venn diagram of art, craft and engineering, explaining that the way I'm thinking about these three concepts, there is certainly craft in art and there can be craft in engineering. I'm not sure how much overlap there is between art and engineering. There are different aspects of programming in all of them though. I'm not going to go into very much detail, at least in most of these, about where I'm putting things. That's for you to do. That's for you to think, well, where does design come in? Is that engineering? Is it craft? Is it art? For some bits I will highlight it, but I want you to go away and think about any activity that you're doing. Am I practicing an art? Am I honing my craft? Am I performing engineering? Let's look at another piece of art. Out of interest, does anyone recognise the artist? I can see why you said Jackson Pollock. This is actually Joan Miró, a Catalan painter, and it was in his 60s. So you'd be more likely to recognise things from the 70s and 80s, as in 1970s and 1980s. He painted a lot of landscapes and things that look quite Picasso-like early on. I really like his 60s paintings, but I don't know why. I have this hung up in my hall, and it's beautiful, and I just stand there and look at it. But I can't tell you why. And that is part of why it's art, I think. I could paint something that looked a bit like this, but it wouldn't be art. It wouldn't be good. I could have a load of dots, but there would be something missing, and that something is really hard to quantify. And I think the same is true in code as well. There are examples of code that I think of as art, and Link to XML is one of them. it's a very odd API. How many of you have used Link to XML? So Xdocument, Xelement, etc. If you haven't, and you're doing .NET and you're doing anything in XML, use it for goodness sake. Get rid of XML document, etc. Link to XML is where it's at. But when you look at it to start with, you may think, what on earth is it doing? It rejects all the conventions that we might normally have. It has a bunch of constructors and add methods and things that take object. It's like, no, I'm using C#. I want nice, strongly typed things. I want to differentiate between adding another element to my element or adding an attribute to the element. Link to XML says, yeah, just give me some stuff and I will do the right thing with it. And it feels awful, and then you use it and it's just beautiful. It uses operators in what feels like weird ways. You know, you can have an X namespace added to a string and it comes up with an X name, a fully qualified name. It's like, that's not really an addition in a normal way, but it does just work. It's got all kinds of implicit and explicit conversions that feel wrong until you start using them. You can explicitly convert a null X element reference into a string, and it won't throw a null reference exception or an argument null exception. It'll just return you a null reference. Like, should it? Yeah. Actually, it should, because it's really, really useful to do that. But it takes an artistic genius to come up with that kind of thing. So is art the sort of the ideas behind things, the invention? There's some relationship there, I think. Not all art in software is in the code. There can be art, I believe, in user interfaces, user experience, but I'm not talking about pretty user interfaces. I'm talking about ones that are beautiful in how you use them. Sure, if it happens to have a nice skin on it as well, that's fine, but it's the experience that matters. And there's one difference in art from code in terms of novelty. So often, and certainly in Sunday in the Park, there's this idea of, have I discovered something new? Am I doing something new or just the same thing again? As if art cannot be something familiar. Whereas in software, yes, we like to be doing something new, but if you decide to make all your names all caps, that's not art. It's novel, but it's not art. I remember there was a CRM system that I used back in the late 90s called ACT, with an exclamation mark, ACT. And it had on the box, unique user interface. It's like, I don't want a unique user interface, I want a familiar user interface. And that makes it quite difficult. If you want to be, you want to have invention, you want to be new, but within bounds of consistency and familiarity. I think that's one of the challenges within code. Going from Miro to my hand-drawn on a Surface Book picture of a hammer feels slightly odd, but there we go. So if that's art, then what happens to craft in code? And for me, craft is sort of a hard-won skill. It's usually part of something else, so I would think usually part of the art or engineering. But it's what allows the art to be implemented, what allows you to take that idea and express it appropriately in code. It's a very fuzzy boundary. So API design, like Link to XML, is that art or craft? It certainly requires a lot of craft to do it well. There are probably going to be bits that are art and bits that are craft. Just as I don't have the artistic ideas of Miro, I also don't have the craft of Miro, so if I were to try to do a Miro-like picture, there would also be the craft aspects would be missing. I think craft in code can't be purely theoretical. You can't learn everything there is about a craft from a book. There has to be a certain element of doing. But equally, a lot of it is studying the work of those who have come before you. And I think this is where craftsmanship and mentoring and pairing all work in a sort of virtuous kind of way. we've had our knocks over time and learnt where things don't go well. Those are lessons that we need to pass on to new generations of software engineers. Because sometimes it's great for them to make their own mistakes, and other times it's great to say, I've made that mistake before, let's not go down there. It's not just doing something lots of times though. Time spent doing coding will make you a better coder if you are deliberate about it. If you reflect on what's gone well and what's gone badly. If you just write the same code day in, day out and never bother thinking about it, you won't get better. So, engineering. This sort of feels simultaneously on more solid ground and also rockier ground. I know that there are some people who don't like using the term engineering applied to software because they mean all kinds of things around engineering that make guarantees about the output that we just, well, I don't think any software engineer in their right mind is going to guarantee that their code is bug-free, etc. It ends up being very worrying. We do our best, but it's not quite the same thing. But this feels like it's more on the objective side. And it still involves skill, and it's still closely tied to experience. But as examples, if API design is sort of craft applied to an art, then I'd say that benchmarking is craft applied to engineering. There's much more engineering in a good benchmark than there is art, but it definitely still requires craft and skill and experience to build it. Likewise, build automation and tests and continuous integration. These are all engineering problems with varying degrees of craft involved. So, if that's all background, how are we going to bring order to the whole through design, composition, tension, balance, light, and harmony? I figure we might as well use Sondheim's words and see how we can best apply them. We could have come up with 8 or 10 entirely different words, but hey, this is an exercise in comparing these three aspects, the visual, fine art, the musical, and code. Excuse me a second, it's extremely hot. Right. So, design. Design is a massively overloaded word, but I'm mostly going to think of it today in terms of the opposite of by accident being by design. It is intention. It is making a choice. In Sunday in the Park with George, George is always deliberate, and Dot is the one who's more spontaneous. But it's actually Dot who provides the best example of this intentionality. When she's reflecting in the second half of the show on leaving George, she sings, "I chose and my world was shaken, so what? The choice may have been mistaken, the choosing was not, you have to move on." The choice may have been mistaken, the choose... Oh, don't make me start. If you encourage me, I'll only sing more.
Encore.
The choice may have been mistaken, the choosing was not. How many of you, and maybe this will be, I'll find out that I'm the only one who has this. How many of you have been paralyzed by indecision when coding? Hooray! Phew! It regularly happens to me, and it tends to happen when I can see 4 or 5 options and I hate all of them. It's far, far rarer that there are 3 options and they're all lovely. We're facing, I can think of about 3 or 4 different examples at work at the moment, some of which are private so I can't tell you about, but that all have, yeah, this sucks because of X, this sucks because of Y. It's like, who are we going to mess up? There's an interesting aspect of choice in software, which is that software changes over time, and some decisions can be postponed, and some can't. Some decisions can be reversed and some can't. And making choices can be hard, but there are three sort of aspects of meta choices which can be harder. One is recognizing the choices you're making, explaining your choices, and recognizing the impacts that making a choice will have. I'll go into each of those, not necessarily in that order. So, what is this? This is a C# method declaration. What choices have we made here? So there are some obvious ones. We've chosen that it'll be a void method. We've chosen the name will be foo. We've chosen that it's parameterless. We have implicitly chosen that it's an instance method. It's not static. It doesn't have the unsafe modifier, although it could still contain unsafe code if it's in an unsafe context. We've implicitly left it private. We've implicitly not made it virtual. Now, being private, it wouldn't make much sense to make it virtual anyway, but imagine, those are two relatively orthogonal things. Interestingly, in Java, it would mean something different. The default would be package access, which is a very strange access level that's possibly ill thought through in the Java design. And it would be virtual by default in Java. Now, these defaults are really important because of the number of methods that I see like this. I've worked on significant amounts of Java and C#, and most methods in both languages don't have either a virtual modifier in C# or a final modifier in Java. Most of the time people stick with the defaults. And there's no reason why that should be the case. They're not such different languages that it makes much more sense for almost all Java methods to be virtual and almost all C# methods to be non-virtual. This is a choice people are making without being aware that they're making it. And without being able to say that they are making it. Unless they decide, you can explicitly say, I'm making a choice and I will make it virtual in C#. You can explicitly say, I'll make it final in Java. You can't explicitly say, I'll make it virtual in Java, or explicitly say, I'll make it non-virtual, unless it's overriding a new seal in C#. That's an oddity. The difference in terms of access modifier is interesting in terms of language design for how you choose a default. If you're going to have a default, C#'s approach is that if you don't specify an access modifier, it's always as private as it could be. There's one corner case for that, which is if you've got a public method, if you do public foo, property, and put a get and set, then you can make those more private by adding private get or set. But in general, not putting anything makes it as private as it can be. Which is a good thing, because if you change your mind later, you're going to make it more public. And you'll notice that in a non-breaking way. Making something, taking it from private to internal or public is, generally speaking, non-breaking. If you decide in Java, oh no, I made this package access and I forgot to make the decision, I forgot to make it private. If you make it private, that's a breaking change. So, when we are making these, writing a method, you would be shocked if I told you exactly how many decisions you are making. Okay, because there's all the kind of things that we don't think about to start with. Like, is this an extern method? Well, I could count the number of extern methods I've declared on the fingers of one hand, and only for demonstrating interop that I don't actually use in production. All kinds of other things. There's virtue, I believe, or value at least, in being explicit. But we can't be explicit with every decision we make. If we did, our method declarations would be huge. But where we can be, I would encourage us to make the decision and communicate that we've made it. I'll come back to communication in a bit. Second is working out the impact of making a decision. And this is where I've become interested in versioning in the last 2 or 3 years. You know, I thought date and time was a bit too exciting. I would find another relatively niche thing to be interested in, and versioning is it. It's fascinating how these days, you know, how many of you pretty much understand semantic versioning? Right. How many of you think it's well defined? Good. Because it's really, really not. There are so many things that when you try to say, okay, you can take the basic principles of semantic versioning, how does that apply in a method? If you make a method that used to throw an argument null exception if you passed in a null value, if you stop it from doing that, if you make null a valid value, is that a breaking change? Well, someone could be relying on that behavior of throwing an exception. So in that sense, it would be, but most of the time we wouldn't expect it to be. I have a blog post that I started about 9 months ago that I haven't yet published, trying to catalogue what I consider to be breaking and non-breaking changes, and you know what should be in a minor version, what should be in a patch version, what should be in a major version. I think I might have to turn it into a wiki or something instead, because otherwise it'll never happen. But the important thing is that when you make a decision, whether it's making something private or not, some of these things affect versions in a way that locks them in forever, or locks them in until the next major version. Some postpone them, and some have a balance between expressing a stable expectation to users or not expressing anything. If I choose not to make a whole type public, I may be reducing what my users can do with my library, but at the same time giving me more flexibility to change things later on, and also meaning that I don't need to explain something. In Nodetime, how have I got this far without mentioning Nodetime before? In Nodetime we have a type called local instant that was originally public. It never made it into V1 being public because it was too hard to explain. And I took the notion that if I can't explain something reasonably concisely in public documentation, then it has no business being a public type. Let's talk about communication. So if you're writing docs, I would say be explicit where you can be, where it makes sense to be. So I always write private explicitly. I didn't used to. Eric Lippert suggested that it was good to record the fact that you have made a decision about that. I think those were wise words, as they tend to be to Eric. But you need to be deliberate. You need to choose which choices you document, and comments are a great example of that. A well-placed comment can save hours and hours later on. On the other hand, if you commented every single line, that would be worse than not having any comments at all, because the signal would be lost in the noise. Another example of where explaining choices has proven to be a treasure trove, back when Eric used to blog more about C#, he used to often refer to language design meeting notes, even from back before he was in the C# design team. And they were a real treasure trove of why the C# design team had chosen to do things in a particular way, and the options that they had considered. I don't know how many times we've all fixed a bug and then it's regressed because someone didn't understand the decision we've made. I have that in a very physical way. The reversing, I have a 15-year-old car, and it has a reversing detector. Not a smart camera or anything like that, but it has something that's meant to beep when you're getting near to something, except it hasn't worked ever since I bought the car. And every time I go into reverse, it beeps and flashes a light to say, hey, the reversing detector isn't working. So I got a garage to disconnect that. I paid £20 for that, for the privilege of them disconnecting it. Then the next garage then charged me £20 to reconnect it, because there was no log of the decision and why it had been taken. So choose what your choices, which of your choices need to be documented. I don't think you need to choose how you chose which of your choices to document. There's only a certain level of meta that we need to go there. Okay, so if that's design, oh, one other aspect of design, yeah. I've mentioned representation a couple of times already. This is a quite different type of design. Sunday in the Park with George is interested in the sort of layers of representation of sort of myth and reality of actor versus character versus figure on a painting. And while I won't go into much of what design means to normal software engineering, I will think about this idea of modelling. As software engineers, we look at the world that's something really complex, and we have to trim it down to something simpler. Seth did that earlier on, taking a picture of potentially, infinite precision. If you're actually writing something on paper, there are atoms there. It's not at the granularity of 28 by 28. You're doing a simplification to start with. You're then making it just black and white or grayscale. You're then trying to recognize it. All these are layers of simplification. And that's a lot of what the job of software engineering is. And that's one aspect in which I think it's similar to art. If you look at a photo can be perfectly accurate representation. I could take a photo of you now, and everyone would be in focus, so you could see the reality of what there is now. And that wouldn't be art. It would just be an accurate representation. Art is finding something else in a representation. Finding whether it's a composition of putting two ordinary things together and getting new meaning from seeing one next to another. Or if it's not photos, if you are drawing, then deliberately exaggerating some features. You hear about portraits capturing some elements of a person in a way that almost shouldn't be possible in one image to capture so much of a character. And that's what we have to do as well. Again, I can't remember actually whether it's Dot or Marie sings about this. She sings, "The child is so sweet and the girls are so rapturous. Isn't it lovely how artists can capture us?" And art is when we manage to capture what's important about some aspect of the real world so that we can put it into a dumb computer that can only deal with ones and zeros. I'll give you another Noda-Time example. Dates. You might initially model dates as just a year, month, and a day. Well, Noda-Time takes it a bit further than that. It has year, month, day, calendar system. I thought that sounds pretty good. And we've gone for a long time with that. And then someone filed an issue saying, could we support the Bardi or Wondrous or Baha'i calendar? Yeah, sure. Okay, tell me about the calendar. Well, it's interesting because it's 19 months of 19 days, except there are some days that aren't in a month. What? Yeah, you look at these 4 or 5 days each year, and they're not part of any month. Noda-Time can't capture that. The model just says, no, does not make sense, does not compute. Is that a fault of Noda-Time? Well, it's Noda-Time's designed to fit a certain set of use cases. It didn't fit this. We have got that calendar now with a sort of a caveat of those days count as part of the 18th month. Those aren't even days at the end of the year, which would make it at least slightly easier. They're just before the 19th month. It's very strange. And then the one person who's interested in this is then writing another library over the top, another abstraction to be able to use Noda-Time and still have a representation that makes sense for what they're doing. So we've got this interesting way of representing the world, looking at it through a particular lens for the application that we're trying to build or the library we're trying to build, knowing that other people may need to sort of squint a bit and look through a slightly different lens. Okay, that's it for design. I don't have this much on each of the words. But composition is obviously another one that is quite near and dear to our hearts. So there are lots of different aspects of composition. I'd say all code is composition to some extent. We make big things from small things. Or to put it another way, we take big problems and solve them by splitting them into small problems and smaller problems until it's a single expression or a single statement or whatever. The interesting part for me about composition is where the value comes in. Because we end up with something both in art and code that is the whole is greater than the sum of the parts. You can take two fairly ordinary photos or figures that you're going to draw or whatever it is, and the act of choosing to put them together in a particular way makes a statement, adds a point, turns something into art. The composition in the painting comes in various ways. So there are the individual brushstrokes. This is an element of composition in art that doesn't happen in most pictures, but that Seurat was particularly aiming for, getting us to compose colours in our eyes. And if you want to see exactly what that looks like, you've got two options, both of which are great. One is to look on the Google Cultural Institute. In fact, three options. One, you could go and see, you lot can go and see the picture more easily than I can, and look really closely. Or you could use the Google Cultural Institute, which has the painting, and you can zoom into an incredible extent. I don't know how they scanned it quite so accurately, but it's amazing. Or the third option, which is frankly more fun, is to watch Ferris Bueller's Day Off. Because most of the way through there's a charming montage there, and Cameron looks at this painting, and there's an alternate zoom between, sort of set of shots between Cameron and the girl right in the centre, or at least it feels like it's right in the centre. I'll show you who I mean, because I always think she's in the centre and she's not really. She's a bit over to the left compared with the actual centre, but it zooms into her face, and from here, even looking quite closely, it doesn't look like there's much there, but by the time you zoomed in, it's incredible. This is an interesting figure, by the way. As well as the light reaching our eyes, Seurat was interested in light and shade, and almost all the figures are in shade of some respect. So this woman here that's in the shade of this woman. Somehow, a woman with a fishing rod is a symbol for prostitution. Not quite sure how, but that's 19th century France for you, apparently. But most of these figures being in shade, a lot being in the shade of a tree or the shade of other characters. The girl, she's sort of shading her face with her hat, but otherwise she's entirely in the light, and she's the only one looking out at us. There's something that draws you to her, and certainly drew Cameron in Ferris Bueller's Day Off. So, composition in code. We've got composition in art that way. There are a bunch of ways that we have composition. This is the most obvious, possibly, is we take statements and we build methods. And we take methods to build types, types to build assemblies, assemblies to build systems, systems to build other systems. And it keeps just being bigger and bigger. And we discovered in the last 5 years or something, microservices. Like, this is not a new idea. This is the single responsibility principle writ large. And it's all just this at a grander scale. There's something beautiful about the way that composition happens at so many places in the software chain. And we've seen what happens when it doesn't happen properly. You may have been thinking about composition in terms of types. You know, the advice of prefer composition over inheritance, so building one type out of multiple types, data composition rather than executable code composition, if you like. And what I find interesting here is again where the value comes. So it's partly a choice of what types you combine together, but there's also another kind of value that's added, and it makes all the difference in the world. Anyone care to guess what I'm referring to? Names. If we just got, you know, the purple square is composed of a black circle, a green square, and a red triangle, that would be one thing. But by naming them, I mean, these are very abstract names, by giving them names, we attach meaning to those values. Imagine an interval type that has a start and an end. That's very different from just, well, here are two instants in time, or whatever it's an interval of. As a thought experiment, think about the sort of 3 data points on a line of the tuple of T and T1, T2, T1, T2, T3, etc. types in .NET 4. They are pure composition of types with no meaning attached whatsoever. C# 7 tuples that have language support, I don't think would be worth it if they were just a wrapper around tuple of T without anything else. But they allow you to name the elements, and suddenly you're giving, if you're returning that from a method, you're giving the caller so much more information. The same amount of data, but more information, because you're attaching meaning to those pieces of data. But then if you want richer composition still, you put it in a properly named type, because suddenly you can say, I have a start and an end, both instants in time. That means I can work out a duration. That's a useful idea when there are two instants, when you've got an interval. It isn't a concept that makes sense with only one instant. As soon as you put things together, more possibilities spring up. As another slightly meta point, yes, doing this provides information about that type if you choose to use it. Making it available gives information that this is a useful thing to do, that may not always be obvious. Again, it's a choice, again, it's what you make public. But there are times that you may have abstractions, compositions in your code that make sense only for one very niche situation. So you hide those away. I'm not telling you anything you don't already do. This is not a guide to learning something new. This is a guide to thinking about what you're already doing. So you hide that away. But at other times you say, do you know what, I use this idea of, you know, these three shapes coming together. I use that so often, I'll make that a type that I can use from multiple places. And that's conveying information to a future reader, saying this is a more general usage thing than just the anonymous types that you would use in a link expression that's just for the sake of this query. Sondheim has something to say about that as well, this time from Into the Woods. The witch sings, "Children will look to you for which way to turn, to learn what to be. Careful before you say, listen to me. Children will listen. Careful the tale you tell, that is the spell." The tale you tell in your code, the things you choose to compose in a public way, gives information about what you think is a useful thing to do. Next comes a slight, I'm not sure the best way to describe this. It's a different kind of composition, and I'm not sure whether it's just that it's functional composition, or whether I'm reaching for some other concept that I can't expose properly. But I can give you two examples, which are link and async. Now, both of them actually have language support in C#, but that's sort of irrelevant. The interesting thing is they compose. Not with each other, but link composes with itself, and the way that we use async composes with itself. You can take the output of one link expression, say a where query, where filter, and then apply another link operation, whether it's a projection, ordering, whatever it is. Because we haven't changed type, or at least not radically, we've changed it from an IEnumerable of t to an IEnumerable of something else in the case of a projection. But it's the same general shape, and that allows us to compose multiple operations together. Likewise in async, the things that you consume in an async method are task-like types, and you can consume them in a particularly easy way by awaiting them. And what's the result of an async method? Another task of t, which means you can call one async method from another, from another, from another, and build them up and compose them. I think this has something to do with monads, or co-monads, I think, in the async case. But I don't know enough about it to be able to express it succinctly and correctly. If I did, I would probably look smarter. But do you remember how I know I like the Miro painting, but I can't quite put my finger on why? It feels like async and link are sort of the code equivalent of that. I can see that there's something behind the scenes of great beauty, and I can tell it's beautiful, but I couldn't explain to you why it's beautiful. So I think those are aspects of art shown in composition in code. Okay, I'm cheating on the next two words because I couldn't think of anything positive that's tension in code. If you can, please let me know. In art, there's often tension that's a good thing. In Sunday in the Park with George, something that I wouldn't have known if I hadn't read interviews with Sondheim, he has, and I think it's for the chords that are played, they're sort of split chords that are played when design, composition, tension, light, balance, harmony are said, they're chords that are missing a bottom note. There's a bottom note that feels like it should be there, and it doesn't come until just after harmony. And if you listen to it, as a listener, there's something missing, there's something missing, there's something missing. Ah, there it is. That tension, that cliffhangers from soap operas or anything else, there's tension in art as a good thing. I don't think there is in code. There's plenty of tension, it's just that it's not good. So we have to find a balance instead of tension. We have to balance competing demands of which project are we going to work on? Are we going to fix bugs versus develop new features? Are we going to expose things publicly or keep them private? All the choices we made before, a lot of those choices are between competing concerns. There's particularly interesting tension in language design. Over the last few years I've been working in the ECMA C# committee, standardizing C#5. So Microsoft has had a C#5 specification for many years, and you would be amazed at the number of issues we've managed to raise with it, and work through most of them and hopefully come up with something, a better version of C#5. Entirely compatible, it's just slightly more precisely specified in most places. But in language design, you've got loads of features that you would like to be orthogonal, so you can talk about generics, or you can talk about optional parameters. And are those entirely orthogonal? Well, they're really not when it comes to overload resolution. And frankly, overload resolution is the nexus of all evil in language design. Yeah, almost everything you do will affect overload resolution. And by the way, neither the Microsoft specification nor the upcoming ECMA standard does overload resolution and generic type inference properly. you can really, really easily come up with a method declaration or a method invocation and say, according to the spec, that shouldn't compile. And it compiles and does exactly what you want it to, but trying to specify exactly how is infuriatingly difficult. So much so that we gave it several goes and we've given up until we come back to it. But the point is that when you're coming up with a new feature for C#, you need to think, how does this interact with all the previous features that I've already got? And how does this interact with features I haven't even thought about yet? Are we setting ourselves up for failure later on, unable to add a feature that would be really nice because we've added this boneheaded one now? One other aspect of balance that's not directly code related, but I think is probably relevant, is work-life balance. And in some ways this is the theme of the musical, because George throws away his personal life, or at least he throws away his personal relationships in order to work on the painting. And there's a song about it called Finishing the Hat. And I won't sing all of it, but it is very relevant to software engineers. George sings, finishing the hat, how you have to finish the hat, how you watch the rest of the world through a window while you finish the hat. The rest of the world can go hang while you're in the zone. Does it need to? Just because you're being fantastically productive at 7 o'clock at night when your wife's saying dinner's on the table, or where's my dinner because I've just come in for a full day of work and you were meant to be doing the cooking today, there's no need to stay in the zone. I'd encourage us all to pay more attention to work-life balance. But, I can't get away from the end of that song, which is, look, I made a hat where there never was a hat, making something out of nothing, which is why I code. It's such an empowering thing to do. But remember, there's power in our relationships too. Light. I'm glad it came out. I'm always worried when I do yellow on slides whether it's just going to blend into the white. So, in the painting, we know that Sura was experimenting with light. In the musical, we hear gossip that Sura has been seen walking around in the middle of the night just staring up at the lamps to see how the light works. So how on earth am I going to tie this into computing? Well, for the purposes of this talk, I will think about transparency and openness. Think open source. Shedding light on the world of code, maybe on data as well. Making everything open and light where appropriate. I'm not going to say that we should all be open sourcing all of our code, making all our data public, but where we can, doing so, and communicating that clearly. Because there's another interesting thing about light, which is if you have too much of it, it's no good at all. And if you enjoy driving, either, well, I don't know what time of day it would be here, but sort of 3 o'clock in the afternoon yesterday. Wow, was that only yesterday? I drove around the whole of the M25 yesterday. The M25 is London's biggest car park. It's the motorway that goes round the whole of London. And I went from one side of it to the other to pick up a doll's house for my wife's birthday. And on the way home, the light was just there. And so it was really hard to see anything because there was too much light. A deluge of data is like a blinding light. So again, imagining comments on every line. We shine light on something by giving more information, not necessarily more data, by making our meaning, our intentions clearer. I would say that things seem to have gone through a reason. I was going to say minor revolution. I don't think it's actually terribly minor in terms of open source, and I'll credit Microsoft with a lot of this. Microsoft doing work in open source is fantastic, and I wouldn't be in the role I am at the moment without .NET Core being open source, I strongly suspect. Our final word, harmony. This is a picture from the score at this is the last word in the first act, when the whole of the cast is on the stage and they are singing in harmony. If balance is a compromise between competing elements, then harmony is multiple elements improving each other, just like composition is, but with entirely different elements. I would say here, we're talking about more than code. Even if we're talking about our industry, we're basically talking about people.
Teamwork.
Teamwork, but beyond teamwork. So how do we produce a harmony of people? And here I want to go to a different analogy, which is a choir or an orchestra. If you're going to be a good chorister or good in an orchestra, you need to know how to keep yourself quiet. You need to learn humility. You need to know how to make your voice blend with others instead of overwhelming them. And a good team leader is like a good conductor for an orchestra. They will help keep that balance. And a good team will help the conductor with that correction. If someone has been corrected because they were playing too loudly, a good team rallies and goes with the flow and gets that balance right, without recrimination, but with compassion. And a great team doesn't need the conductor's permission to point out when someone's being too loud. You can probably guess where I'm going here to some extent, and I can't believe I've gone 56 minutes without mentioning diversity yet. But I want to be playing in an orchestra. I don't want to be playing in a brass band. I love brass band music, but isn't it richer when there are the different pitches and the different tones of all so many different instruments? That's where software as an industry has to be. And it is more than just teams, because we don't just work with our teams. Just go back to the painting. This surround was added by Sura in a later phase. And I think of that as everything that needs to surround our work. I'll give a concrete example. So I work on Google Cloud Platform, making it rock for C# developers. Okay, that's my team's job. In order to do that, I need to listen to people who are producing APIs. So I particularly focus on client libraries. So take the Google Cloud Vision API. If you don't want to recognize digits, then you can ask Google Cloud Vision API to do so instead. I write the library that connects your code to their code. So I need to talk to them and other API producers. I need to talk to the team responsible for the code generation, the team responsible for protocol buffers and gRPC, the RPC mechanism. And I need to be part of Google Cloud Platform as an organization and know where their priorities are and fit in with that. Beyond that, I need to listen to customers. I need to talk with the people writing samples. I need to listen to those customers in GitHub and mailing lists and internal mailing lists and on Stack Overflow. All of those influence my work. So within my own particular picture or song, I may be singing the melody, but I need to listen to their harmony to make sure that we're still making a nice noise together. And I need to be aware that from their perspective, they have their melody and I'm providing harmony to them. Now all of this sounds extremely fluffy, and wouldn't it be lovely if, and I'm not going to say it's easy. All I will say is we pay an awful lot of attention to things in code, and we don't pay nearly as much attention to humans. And I think we'd be better off if we rectified that balance a bit. My other point about this is it really doesn't fall into that Venn diagram of art, craft, or engineering. forming and maintaining relationships. It's a background, a working environment. Skip all the way back through the slides. So, to conclude, we are lucky to work in such a creative environment that also contains engineering. I don't know anything like it. I've tried to convince you that software is and can be an artistic endeavour that's grounded in engineering. And I've also tried to persuade you that it's more than bits, that the humans aren't just a leftover part. They need to be much more in the focus. We can always do more, but I want to end with the end of the musical as well. White, a blank page or canvas, his favourite. So many possibilities. Thank you. Does anybody have any questions? It's not really a sort of questions-y type talk in general, but whether questions, comments, just musings. It's fine if they're on.
Don't let me stand here. Stop. Ask away.
Yeah.
Well, in some ways, we have to finish the painting because it's just points of color, and he knew that. Seurat understood that the eye itself was completing the picture, and I think in software, the user has to basically finish the software, whether it's the developer consuming the API or an end consumer has to sort of finish what was intended by the program.
It's certainly, the software is no use unless it's being used.
Yeah.
And the more that we think about the user's part in using the software, I think the more value there is. Yeah. I think I'm with you.
Because I can write some very good software, but if someone else just doesn't get it,
yes.
Then
Oh yes.
It's not done.
And that's where things like when talking about the surrounding thing, you can write a greater library as you like, but if it's got no documentation, so no one knows what the heck it does, then it's pointless. And likewise, an application that has no explanation of what it's trying to do. I've used far too many applications that I'm sure would do what I want, but they provide no clue as to how to do it. And sometimes that's been seen almost as a point of pride in some app developers, it seems to me.
It was hard to write, it should be hard to use.
Right, exactly.
I like that.
Thank you. There was another comment over here.
I had a quick comment on the tension.
Yep.
Were you talking about tension? Don't you think that tension is what's happening before you get to the solution? Like a really good solution, there's a lot of tense and anxiety, tension over what decisions are going to be made.
There is. I'm not sure whether I'd say that's a good thing.
Yeah, you kind of said it was negative, right?
Yeah, I think anywhere that there's tension and we can remove tension, it's worth removing it, whereas that's not true in art.
Right.
That was the sort of contrast I was trying to make on that. But yeah, I mean, if we're all casual the whole time, that doesn't sound like the software engineering industry that I know.
Right.
But yes, I think actively recognizing tension and also recognizing when we are too tense about something to do work well, and when we just need to take ourselves off and go and have a coffee or take the afternoon off because we're no use to anyone as we are, if things are just too tense within us. Definitely. Yeah. Sorry, yeah.
So you're trying to and this gentleman, tension, the statement on tension is negative, so it's always going to be difficult to, I would suggest, without tension, we do not grow, we do not move.
Without tension, we do not grow, we do not move.
It's natural.
I would certainly agree it's natural.
And if it's not there,
I think I'd say that's about struggle. And I know something I know Sondheim has said, if it's not hard, it isn't worth doing.
No, it's natural tension. It keeps us thinking, going. Even without minds, the plant has to create tension to break through the sunlight. And so thinking about tension in the non-negative term is basically making a statement that it's tension. If you're looking for a positive tension, maybe that's how you should look at it instead of.
I think I'll need to think on that. I think I need to try to think of examples where there is tension. Is there a case where there's tension that can be removed, but removing it would make things worse rather than better?
Sure. Plants grow.
I mean, within software.
What about where you agree to disagree?
Video games.
If you take away the tension in the development of software, does it become something? No. You need to continue to push the tension in order to get it to what you want it to be. Parallelism to a plant. It needs to grow, flower, everything else along those lines. Software is a similar thing. And it's good.
I think we probably use tension to drive ourselves, but that's a correlation rather than causation, if you see what I mean. But I will need to ponder that. And if you have any more thoughts on it, or if anyone has any more thoughts on it, please email me. My email address is on my Stack Overflow profile, by the way. There was a comment from back there, and then we'll come. Yeah?
So I'm just thinking, like, in terms of tension, an example of how tension can drive improvement is like how our software often gets more elegant and more compact and more efficient as we match hardware applications. And everybody in the whole world had a 1 gigabit per second, internet connection. There wouldn't be nearly as much of incentive to shrink things down and compression and caching and things like that.
And would that be a bad thing? If
So having limitations that push against what we want to do often make us more.
I half agree and half don't. In that I think having artificial constraints. So I can see how, again, in art, the tension, the constraint of a haiku is half of what gives it, makes it feasible for it to be art. I think where we're constrained, and I'm remembering the Visual Studio 2010 cycle, where it performed like a dog, and I believe the Visual Studio team were all told to go to Target or whatever and buy the worst machine they could and install their code on that, and that's what they had to work with until it was usable again. That was when Visual Studio first started using WPF, and WPF got a lot better because of it. On the other hand, if the tension didn't exist because the constraints didn't exist, if we had infinitely fast processors and infinite network, then making things more efficient would be pure waste. So, I don't know, I half agree. But this is cool. This is clearly one area that I will need to work on and think about over the next few days.
Argument goes to engineering, though, it doesn't go to art. Again, your haiku point, that is an artificial
Yes,
too.
yes, absolutely.
I would argue that even if there were no constraints, it still wouldn't be wasteful to be more efficient and more elegant. Just because my friend has an hour in the afternoon that they're not doing anything to listen to me talk about a story, doesn't mean there isn't, there isn't elegance in saying the story in 5 minutes.
It depends what the point of. So my experience is that usually elegance and efficiency in code are in tension. That I can have an elegant solution or an efficient solution, and if the only elegance is in terms of efficiency, then it gets a bit more dubious. But I have to wonder if I'm spending time to make something more efficient where there is no constraint, where we have infinite whatever it is, wouldn't my time be better spent doing something else on it?
Well, put it another way, imagine that you're working one job and you have no constraints, so you don't be more efficient. Then later on, you're being considered for another job because you haven't had that constraint, that tension, your skills haven't developed to the point where you follow it. You're not ready for the next challenge.
but wouldn't developing another feature or something also develop skills? I think we should probably call a halt on this one, partly because at the moment we've got one-to-one, or many but individuals to one, whereas you could be having more efficient discussions about this in the kitchen or whatever. But this is clearly a key point to look at more. Any other? Yeah, sorry, I'll just come back to you first to round off. Yeah.
Oh, I thought you were. Throughout your presentation, I noticed something that you're staying in two-dimensional world. Art is not two-dimensional. It's a multi-dimensional. Is the programming the future? I agree today, it's binary, it's boundary. Is the future? It's not going to be. And we need to rethink how do we program dumb devices. And looking at art will that help us? If we understand that art is not just painting or picture. We presented that, but we didn't make a correlation in my mind.
This is because I'm not an art critic, or
I'm not looking for art critics, right? Because basically, isn't that a message you're sending here? That art, including music, the feelings you're having, things along those lines, and you've tried to map that to that, but it's still, you're limiting in dimensions, because we're facing, the new machines.
Yeah.
We're already beginning to face those.
Yeah.
And thinking that we need to break away from is under a single
Yes.
limited dimensional. And I'm wondering if your talk can help in that.
It almost certainly wouldn't help on that. It certainly, that's not something I have considered. And the message, as you said, messaging of art being two-dimensional was not an intentional message, and one that I think I'll need to work on a bit and think about what I am messaging. But I have no idea. I have no idea whether programming really will change to such a radical extent. And if it does, it's sort of Blobb's paradox. Is it Blobb's paradox? That I can't see where it's going in any way, shape, or form. So I can't say whether talking about art is going to help us get there or not. If it happens to, if I manage to spark some great aspect of creativity in someone else, that's fantastic. But it's not what I'm aiming for or could aim for without knowing more of the roadmap, as it were.
I guess I know.
Sorry?
I'm saying you're onto something.
Okay.
You're onto something.
That's cool if I am. Yeah.
Because I'm looking at how we're going to program these beasts.
Right. It certainly wouldn't hurt to look.
It's breaking a paradigm.
Right.
We've broken paradigms before, but this one's going to be really hard.
Yeah.
And so maybe you're on something. I appreciate it.
Cool. Thank you. There was a point here.
Well, I was just going to make a comment. One of the features that I've seen recently is the advent of things like customizable software. Two people are using the same software package and it's completely different.
That's
almost like you've got a pivot table. Like they decide, I want a tile view, or I want to grab this way, this is my home page, and these are my colors and things. And sometimes that's what's amazing to me is like well-written software allows that so that it's, different people have different preferences.
There's a quote, I think it was Strustrup, about C++, saying if it would be a failure if people could only use it for things that I could imagine. And the interesting thing I find about C++ is it's not a programming language, it's something you build a programming language from, depending on which particular conventions and aspects of C++ you'll allow and which you'll ban and whatever. I know that I don't do C++ at all, but I know that C++ at Google is quite different from C++ at Microsoft, is probably quite different from C++ at other things. Much more than Java in most places is going to be pretty similar. But yes, I think spreadsheets are a great example. You were saying about pivot tables, that people use, and one of the reasons that Excel succeeded, at least according to Joel Spolsky, is, well, was it VisiCalc was busy doing heavily spreadsheety things. Microsoft noticed that Excel was being used for creating lists of stuff, so they made that really easy. And then people have gone and done all kinds of things from it. Yeah. Yeah.
Well, just a comment on what you mentioned, that in terms of the large companies, that seems like something of a problem, very open and different way.
Sorry, when you open something different, it folds.
Yeah, it's like some of the
Right.
puzzles very.
Yes, yes, I know the kind of thing you mean. Yeah, I have no idea how we write code that folds in different ways, but I think that's a potentially helpful analogy. Did you have a comment? I can't remember whether I missed you out. I was sort of trying to keep track of
I did.
which
So I actually wanted to. So humorously, I actually was in a tech, like it was a developer community talk at work, and I had a. It wasn't. I wouldn't say heated, but there was a little bit of tension between myself and another developer. It was passionate. There you go. That's the word. About the role of or the developer, or software engineer being an artist versus an engineer.
Right.
And I was hard on the engineer side, and I have to say you brought me back to the middle on that.
Hooray!
So thank you.
Cool.
But I also kind of wanted to talk about the and I know it's been beaten to death, but at this point the
spaces, not tabs.
That's been beaten to death for sure. But I know that I don't necessarily need tension to be motivated, right? So like and I not bragging at all, obviously. I'm sure a lot of us do this too. But like I go home and I work on robotics projects. I work on woodworking projects. I work on, but that's because I want to learn these things and I want to expand my knowledge because I find enjoyment in that. And I think that what I find is like, through building relationships with a lot of developers around me, there's kind of a tension created between the management types and your software engineers, because your software engineers tend to be very self-motivated individuals. We don't necessarily need somebody to hold our hand and tell us this needs to be done by X. We want to get it done too. And so I think that there tends to be an unhealthy relationship there that could be due to a lack of understanding of what really motivates us. We just want to play with new toys and make new things, right? So.
And different people will be motivated differently. And where you were saying about having a passionate debate, and that can be healthy as well. Mm-hmm. But I think you originally described it in terms of tension, and this is something I meant to effectively bring in, and I wasn't sure whether to do it explicitly or not. Google runs longitudinal studies on teams and individuals, and has been doing quite a lot of work in terms of psychological safety, and how you can build a team that can have discussions that are passionate without being tense. That's how can we get it so that there can be healthy disagreement, because a team that doesn't disagree, again, there's loads of data behind all of this, a team that doesn't disagree or doesn't feel able to disagree is unhealthy, and likewise a team that disagrees via screaming matches and putting people down is also unhealthy. So how do we take what currently we find a positive in tension, if there are heated debates, and turn them into passionate debates that everyone feels comfortable being in? That sort of psychological safety is a lot of what I wanted to get at in the harmony section. And again, I'm not going to pretend I know answers to how you do that, but I think if we're conscious of trying to do it, and conscious of trying to encourage voices, either voices that aren't present because they're not in our organisations at all, or voices that are typically unheard because they're not encouraged enough. I think just being aware that we need to do that is the first step in doing it, and we can work out how to fine-tune how we do it as we go along. Yeah, any other comments? Are we all? I'm certainly very hot and quite sleepy. You're probably slightly less sleepy than me. But is there still food and drinks and stuff? Right. Go chat about it more, and then send me feedback on kind of Wednesday.
So I already packed away. I also have a special gift for you that is also food related. So you might be very happy. Oh, I'll show you. It's in the fridge. And then there's also coffee. I almost brought you coffee in the middle of this thing. But I figured speaker like adrenaline would keep you going.
Yeah.
There's actually a coffee machine out there.
I think I'm going to avoid coffee now just because of the long drive. Coffee, not a great. Thank you.
Thank you. It's a pleasure.
Thank you. Me too.
Let me grab everybody. So, everybody seems like they need like a minute. So, we still have some swag, and we have like our usual closing Meshuggah. So, feel free to go. We'll do that in like 5 minutes since people look like they want to get up and stretch their legs. So, 5 minutes to swag.
Close up to the little girl, and all of a sudden it's just like.
And then it just comes just dots. Yeah.
I don't know too much about.
Let me show you the.
I do know it's quite a miraculous thing.
Yeah. If I go to Google Cultural Institute, the level of detail that you can zoom into is absolutely astonishing. So let's project this instead of. Okay. So.
Yeah, we'll run through it and thank you times for being awesome. Do swag, but
So it's fine. There we go. Right. So let's zoom into the girl's face.
Yeah.
Well, Heather, I'm only halfway there. So that's the level of zoom that we've got. So you can see every tiny speck of it. That's astonishing, isn't it?
That is.
although they're staring.
So I wonder what the total size of the canvas at this resolution is. Okay. Zoom.
Couple inches. Yeah, we actually did go through all the food. So find out about that.
The tension that you're looking for. Tacit code refactor. At what point do we, the business goes, not refactoring. When you make it,
So, it's balance more than tension?
Yeah.
I'm the guy you give your $40 to
you
get
got
the seat.
Okay, it's not perfect.
So right, I didn't talk about a balance of how good is good enough, and that's possibly something I should add in. This is the nice thing about this is an experiment. I can take all of this feedback, and at least some of it will make it into Friday.
Yeah, that's why I'm curious. It's always a tension that I seem to frequently.
Right. I've heard a good guide, which is test your code until it doesn't scare you anymore.
I've never stopped testing. It's always scary.
Okay, I'm interrupting.
Yeah, that's fine.
I don't know.
Oh.
Okay, that's what I wanted to see. Okay, I'm happy. Those are cannolis.
Oh, wow.
From the Alex's Pizzeria has like a bakery and does cannolis too.
Wow.
So,
Would you mind if I got a picture?
Of course.
You want a picture with the cannolis?
Thank you.
Here, I'll
Thank
take
you.
a picture.
It certainly sounded like people were thinking, so I didn't bore people to sleep.
You seriously, like, before we picture, like, normally at the end of a meeting, it's like very sedate. Everybody literally just, like, awoke from breathing. Like, they forgot where they were. They're like, okay, get together.
So I don't need to cut and say
File. Alright. I got about, should be good. That's great. Probably should have waited for the lights.
No, that's fine. That's
Yeah,
perfect.
looks good. Sweet. Perfect.
So the tension thing.
Yeah. Sorry, tightrope walking.
too much tension in the rope, it brings you crashing burn. Too little.
And you're gonna fall.
You can't do your job.
Yeah, I have to say, so one of my favorite Pluralsight videos, I was watching, you were working, I forget exactly what the subject was, but you went off on a tangent. And
No, I never go off on a tangent.
Right, I mean, on,
We were
on
discussing
everything.
this one earlier
Yeah,
today,
that's funny. And you decided to write your own IOC container.
That would be one with Rob Connery.
Yes, that was a brilliant, I love that. That was one of my favorites, yeah. So,
I think that was the same talk. That had something about pizzas and discounts as the strategy pattern. There is a YouTube video where someone slowed that down.
Yeah?
Or slowed down my voice to make it sound like I was on drugs. Like, oh, we're gonna do all kinds of things. Very weird. Why did someone decide to do that?
Because it's hilarious. That's awesome.
Hey, you ended the stream, right? Oh, I just streamed my Gmail inbox. I'm going to erase that bit
I
later.
certainly hope so.
Well, somebody would edit the
I will, as
videos
soon
on
as I-
YouTube.
I'm going to have to now. As soon as it has my bloody details.
There's no signal.
Yeah, I just don't.